Wait a couple minutes. This is the next D3 L2 session with Florian Valeye from Back Market. We're just waiting a couple of minutes to get ourselves all set up on the live streams. We just clicked in on YouTube, which is great. We're about to switch over to LinkedIn. So in the meantime, if you have any questions, please use the Q&A panel for Zoom. In YouTube, just use the chat there. For LinkedIn, same thing when it comes online. And you can also go ahead and just chime in and tell us where you're based out of. For example, hi there, I'm Denny, and I'm based out of sunny but cold Seattle, Washington. How are you, Florian? Where are you based out of?
Hello everyone, I'm Florian and I'm based in Bordeaux in the south of France, and actually it's raining at the moment.
Oh, so you've got my weather basically. All right.
Yeah, I think.
Fun times. All right, well, just give it a couple more minutes and then we're gonna talk a lot about some good stuff about Delta Rust, Back Market, Python, Rust, and if we have time, we'll probably talk about coffee and food and stuff like that too. Like how to properly make French bakery. I think patisserie. I think that's actually a very important topic as well. What do you think?
Yeah, cooking in French is really an interesting topic to share.
That's right. C'est bon. All right, so we'll just wait a couple more. Oh, perfect. Looks like we have the LinkedIn link, so I will start that. And then once we do that, we'll go ahead and here we go. Give me 1 second. All right, I think we're good to go. All right, so hi everybody. Welcome to the next D3 L2 session. I'm here with Florian from Back Market. We're going to talk about this is a vidcast and podcast series. Though if you do have any questions, please chime in while we're doing this live. Please chime in on the LinkedIn comments, inside the YouTube comments, or in Zoom Q&A, so that way we can sort of track everything. Meanwhile, without further ado, I did want to go ahead and start by introducing Florian, who is a Delta Lake committer and engineering manager at Back Market. So, hey, Florian, why don't you introduce yourself and tell us a little bit about your background?
Yeah, sure, Denny. So yes, hello everyone, I'm Florian Valeye. So I'm working right now at Back Market. And my background is always around data engineering topics. I started in a consulting firm working with different company size on many different topics related to the data engineering, mostly with data science and data analytics pipeline. And more recently, I joined Back Market to build a team as a manager, but also a tech leader. And more recently, I switched this position from a data engineering manager to a staff data engineer. So I'm working right now with the data tribe, meaning 3 different data squads around Databricks and other pipelines to make data available on the business and make the right decisions.
Perfect. Okay, so hey, before we dive into, like, for example, how you went down this path about building data engineering pipelines and switching from a manager back to staff engineer, which actually I'm really happy you did, because I'm sort of like you. There's only so much we can do as a manager. Like, what got you interested even to dive into the data space in the first place? Like, or are you like a traditional computer scientist, or did you come in through a different angle? I'm just curious.
Yeah, actually, it's a good question. When I started, I was really a software engineer working on web applications, front end, back end, and I saw the big elephant coming with Hadoop and some strange data science teams working on Kaggle. And it was the good old times to say, okay, maybe something is really interesting on to deal with massive data. And I switched by being a kind of data engineer. He was on-premise cluster on Hadoop. And I worked with Hortonworks or Cloudera, the big stacks, with the first Hadoop versions. And if I remember well, it was a version of Spark, the 1.4. When I started
Okay,
to
got
work.
it. All
so
right.
I remember the ADD and not the data frames, and a lot of pipelines coming in these different directions. And I felt in love with data topics, and I started to work as a tech leader and a manager, but always in this kind of area, because I found the ecosystem really interesting and really deep on many topics.
Right. So in your case, basically, you went from a path of web applications first. That in terms of data, you notice the data science with Hadoop, and then basically that's how you went from that perspective to basically into the realm of Spark. And then basically, just like you called out, Spark 1.4. So we actually had data frames then. Before, I think we announced that back in 1.3, if I recall correctly. And then before that, it was called schema RDDs. I still remember those days.
Yeah, you're right.
So nevertheless, okay, so that got you into the realm of, okay, data pipelines, data processing. So, or like you said before, traditionally you were doing web applications. What I'm curious about is then, how'd you go from basically to the path of deciding that you want to do big data as a full-time job, especially because you did went ahead and start from web applications, to back market? And for that matter, provide some context to the community, like what is back market, just in case some folks don't know what it is.
Yeah, sure. Back market is a marketplace to purchase professionally refurbished high-tech products. For example, you can find a smartphone, laptop, and gaming console. Our mission is really simple: is to build trust and desire for renewed devices, and in the meantime, reduce the electronic waste that you can avoid by buying a new tech. So you can find all these products online, and we are more than 700 right now at Back Market, and we are mostly in Europe, in the US, and we started to have some marketplace in Asia as well.
Oh, cool. That's awesome. So one of the things that I definitely want to dive into is then, okay, so you did use Spark, but then how did you, what made you start going down a path of Rust and Python then? I'm just curious, because this, for anybody who's wondering, I'm definitely segueing or leading to the conversation about Delta Rust, so don't worry. But it is interesting, because if you were a Spark person before, I can sort of see where the Python came from. But yeah, why the jump to Rust? And so I guess how did that path for you start? Was it in back market? Was it before? I'm just curious.
Yeah, actually, the first idea was to use Delta Lake as a main core data pipelines when I joined Back Market. And I remember to re-implement again and again the same thing in Spark, the update, the delete, and how we can have all these ACID transaction in Spark by re-implementing things. And I saw Delta Lake, and if I remember well, it was 0.4 version, open source one. And when I saw the schema enforcement, the ACID constraints, the bronze, silver, medallion architecture, I was really interesting, and I said, okay, maybe we need to use Delta Lake as a main entry point for all the data flows coming inside Back Market. And the second step was, during this time, we didn't have any access to optimize, have a vacuum strategy without having the Databricks product. So I was really interested to get the metadata information, the schema about Delta, but without having to span a Spark cluster, because GVM and all the cost considerations that you can take. And it was really, I started to actually work on a Delta Lake Python library. But I found really interesting project, Delta RS1. It was a Rust library to access to Delta tables, and the Python binding was at an early stage. And I started to implement a lot of things on it to retrieve the metadata. So for read operation mainly, but also for vacuuming or having the schema defined in Python. And it was used inside Airflow. For the scheduler of Back Market to retrieve information and to schedule jobs depending on what needs to be done.
Oh, actually, so this is great. So we talked a little in what you just mentioned, you talked a little bit about how you love the reliability and the ACID transactions from Delta Lake. And so that actually is what interestingly enough transitioned you over, which is basically looking at the metadata, in which you're like, I don't want to spin a Spark cluster for it. That's completely fair. I'm going to go back to that, but I did want to call out a little bit about Airflow, actually, because I'm just curious on how you did the Airflow orchestration. And by the way, part of the reason why is because I'm actually doing a shameless plug as well, that we have a D3 L2 session in, I want to say, early December with Simon Spatty from Airbyte, specifically to talk about data orchestration. So I did want to squeeze that little call out there. But I'm just curious, how are you using Airbyte in your environment then?
Airbyte, we switched from Airflow to Airbyte actually to change our approach when dealing to get data from outside. Mostly at back market, when we use Airflow is to fetch data from external APIs.
Gotcha.
Or for Google Analytics, for instance, and have a way to integrate this into a Delta Lake. For the Delta RS, it was really specific to have more optimization on the data storage, like optimizing, vacuuming, and so on. For the other part, it was to fetch data coming from inside and to plug directly into the Delta Lake. When we switched to Airbyte, it was to not having all the data engineers working in the same code base with a lot of functional knowledge, because you start to implement one DAG, two DAGs, a lot of things coming into the same code base, and you start to have a bottleneck in your team. So we switched from Airflow to Airbyte to have something directly connected to the Delta Lake and the other data platform, and to make decentralization in the strategy of the data management, to say, okay, if you want to change something, if you want to implement your own business rules, it's your job as a squad, at the backend or different teams to work with your data. And it switch and make the life easier on the data engineering side, because we were not the bottleneck anymore.
No, that makes all the sense in the world. Then, okay, let's switch back a little bit too. So the onus was basically not needing to basically spin up something so heavy in order to read the metadata for your Delta Lake tables. Basically, you've built an infrastructure. And at this time, by the way, if I recall correctly, you had built everything on the AWS infrastructure. Is that correct?
Yeah, just to explain a bit the pipeline in the big lines. Yeah, we have the Databricks jobs with open source edition when I created the data platform 2 years ago. And it was mostly to create bronze data, all the history, and the silver, the latest state coming from the database, but also system in place or external API back market. And it was the first step. The second step was, okay, maybe I need to access it. And it was pretty difficult for the team because we relies on EMR inside AWS. So without having something really out of the box to like a Databricks notebook will do right now, we didn't have nothing. So Delta RS was a meaning for us to retrieve some data, small data sets, or to explore, to have audit phase, to launch vacuum. It was really depending on the size of the data tables, but it was really useful for us at the beginning to have this kind of operations, and also a lot for data exploration. That's why we implemented the filters on the partitions to make sure that we can work on small data sets. Of course, if you work on the massive on all the delta tables, it can be an issue when you are dealing with a small library.
Gotcha. So to clarify, basically, you were basically working primarily as an open source aspect of things in terms of things like EMR. When it came to the Spark processing of large data, so Spark, Delta Lake on EMR. And then when it came to smaller data, it seemed to make more sense to basically process that data using Rust. And then I'm just curious, are you typically running, because this is actually a question that just came from the audience, right? It's like, why using Rust over Scala and Python for pipelines? So I'm actually going to slightly change it a little bit, which is like, because you're using Spark or PySpark for the larger data sets, for the smaller data sets, were you typically using Rust to do all this, or were you typically doing Python, the Python bindings for the Rust API? I'm curious.
Yeah, I think for Rust, the first thing personally is I love Rust, since I wrote a bit of the code base, because it's really a powerful language when you start to know it. For the Python Rust library, because it was on small data set, but with the performance of Rust and the safety, all about the concurrency and the way it's managed, it's really helpful when you are dealing with Python. Python is just a binding to access to more powerful items when you deal with small data sets. But yeah, the difference with Spark and PySpark jobs on massive data, and when we deal with small data sets, we rely on Rust, because even if it's small, it depends. Sometimes you need to have powerful access on it, and used via Python. And I think that's it. And for us, we can talk more about it, but it's like a good integration tool with Arrow on the memory management with the Python bindings to have the best of both worlds, we have the Rust and a strong link with Arrow on the memory and the safety management, the dependency management that is really helpful with Rust. And using the Python ecosystem. So if you need to have more contributors, it's pretty useful right now because at back market, everyone is a Python developer on backend, on data science. So it was really useful for us to have this binding.
Yeah, see, there's some interesting analogies that you're actually calling out because it's almost like the same. The Python bindings with Rust is actually similar to the Python bindings with Spark, right? Basically, you get a lot more people who can contribute or who can even just use by using PySpark, with Spark, right? Like the idea is that you just use the Python APIs and they're much more comfortable with it. And then of course, it gives you a lot more flexibility because you can connect to the data science world, right? And all the machine learning libraries and things of that nature. And then it seems like Rust is almost the same. There's an analogy from the standpoint of Rust. Rust, there's a few people who know how to do it really, really well. And yes, we are going to dive into that in a second. And then for the most people who are either not interested or just don't want to do it, right? But they can use the Python bindings and they can still have the power of Rust, through the Python bindings, and you're good to go. And it's really small and it's really lightweight. Have I sort of summarized it correctly?
Yeah, totally. I think it's Rust. You have the learning curve that can be hard when you start to work on it. And as you said, it's more a personal involvement into, okay, I need to learn Rust and to implement something. With the Python bindings, it's completely abstracted. It means that if you want to play with Python, it's fine. You just have the way of connecting to the Rust, but it's pretty abstracted to you. I think it's only Python method or knowledge, and it was really useful for us because everyone can submit a pull request, see an issue, or find something to change.
Perfect. Okay, so let's now talk a little bit about Rust. And by the way, we actually do have it's both a shameless plug and also providing context at the same time here. We actually do have a D3L2 session coming up in early December as well with QP Howe, who's one of the who basically I can probably say is the creator of Delta Rust API in the first place. You'll hear more about the story later, but from him, because I'd rather have him talk about it. But basically, he was given the opportunity to say, okay, that's it. I've got you got 3 months, go build it. And that's basically what he did. But let's dive into some providing here, like anybody who's listening either on the vidcast or on the subsequent podcast, like what underneath the covers, like let's just start with even the first question. Why Rust? Like there was a recent blog post from Simon from from Airbyte about like the Delta Rust and specifically how Rust may take over the data engineering world. There was also another post from Daniel Beach, known as Confessions of a Data Guy, same principle. And even Wired magazine went ahead and recently published a very cool article talking about how Rust may take over as data engineering. So you got involved before the hubbub though. So like, yeah, what are the key context for you as a person who originally wasn't working on Rust, who originally was working on a completely different language, that decided, yeah, I'm going to torture myself and learn how to do Rust?
Yeah, I remember this time. It was since I discovered the Delta Lake and Delta RS library. I found an issue, the first issue to help from the community of the Delta RS and say, okay, I need to see what's going on. I need to change something because I was working on the Python binding, but I need to touch to the Rust core to make the binding. So I started with a really simple features. It was to remove the last slash into from the new array. So it was okay. It's really simple. I would just give a tryout of Rust, and I work on it during 2 days, and I face many walls to say, okay, the compiler say, no, it's not working like this. It helps me to define what would be the best strategy to implement and to test again and again and again. And when I reach the point of knowing the ownership, the concept of ownership in Rust, I was like, okay, it's pretty cool to have these kind of features to retrieve all the pains that we can find on the other languages. And I started to discover more and more about Rust. First, the dependency management. with Rust rate, pretty simple. When you look with Python, you have to choose one between poetry, setup tools, pipelines, and so on. So it's really complicated to have many different dependency tools. You have Cargo. Cargo is the package manager of Rust, pretty simple to use. Everything, CLIP to check so your code base, format, you can do whatever you want. So one tool completely linked with Rust. And Rust is safe. I feel safe when I'm writing a code base because you are helped by the compiler, type safe, but also concurrency safe to make sure to not having null variables, for instance. It can be a pretty something completely different from the other languages. And it was a good error handling that I found from the more modern programming, like the options or the way Rust managing errors. And you have not garbage collector or global the global lock of Python when you are dealing with something. So you avoid data races, you avoid the concept of locking your instance. And yeah, the last point is about the ecosystem. I found Rust is for developers, built for developers, and it was really interesting to see the community behind it with a lot of tools, with Polar, Data Fusion, a lot of Rust crate that re-implement something in Rust because it's really useful. And yeah, the full power. What for me the last point was about integrating a new language with it. Integrating Python and Rust is really simple. I remember in the past dealing with Corba or GNE, it was a bit of nightmare to plug all in the interface and to write this code base. With Rust, it was really simple. With the PyO free library with Maturin, it was really simple to integrate everything. So yeah, I fell in love in Rust and started to work more and more around all the projects because it's really powerful. And the last point is about the carbon emission. Rust is a really good efficiency languages to use. So you avoid also the carbon impact when you are dealing with software. So you are more energy aware about the impact of your application.
Oh, no. Actually, now it'll be a little bit of a story time for me. I hope you don't mind, but I still remember. So there's a gentleman by the name of Frank McSherry. He's actually the CTO of a company called Materialize. And the reason I bring this little story up is because he actually has built some pretty interesting stuff like a streaming database that is basically built entirely on Rust. And if you actually look at his past blogs directly on his GitHub, basically that's where he blogged it. He would talk about like how to be much more efficient, memory management, things of that nature, which you and I are going to switch over to the JVM real soon, by the way, and talk about that for a second for JVM and GC and all those other things without rat holing. Otherwise it'll be an hour and a half of just that. But the reason I bring this up is because I still remember how so Frank and I knew each other back in 2007, I think. So it tells you how old I am. And the reason I bring that up is because he and I were we actually were working on a completely different product at the time, systems at the time. We were actually working on differential privacy at the time. But the reason I bring the story up is because we would get into debates, friendly ones, right, which is like basically, oh yeah, like a distribution versus much more memory efficient. And I definitely went down the distribution path, right? I'm like, no, we're gonna forget about uber efficiency of memory. We don't need it. We just distribute our way out of the problem, and it's not a big deal. And so, of course, that naturally led me to go ahead and go to Spark because I'm like, no, I don't care about efficiency anymore. It's fine. Just toss more in, and we can have linear scale, and we're done. And so now, even though I've been working on Spark since 2011 or so like near the inception of its product, I do want to call out and apologize to Frank to say he won the debate. Like, yeah, like even I'm a huge Rust fan right now, right? Because I'm like, yeah, we can, like literally I can see jobs that would normally take multiple nodes, multiple clusters. And I'm like, yeah, I've got like a single, like, or two vCPUs that basically can do the same thing. And I'm like, okay, yeah. So we're very much on the same page on that one. So, which generally leads to my next question, like when you talk about the garbage collection and when you talk about the memory management, like, do you feel like even because of the in-place type safety and in-place memory management that Rust provides, like, does this allow you to even just code more efficiently because you don't have to think about GC, you don't have to think about the JVM anymore? I'm just curious from your own workflow perspective.
Yeah, I think it improves your programming skills because the way that you will write code, it will be more efficient because the concept of ownership and all the things that you have in the past to deal with is completely removed, and you have a lot of high abstraction because I like in the past I am more about functional programming when I'm writing with Python is the same, a bit of the Scala world, but I found all the iterables, the closure and the pattern matching, everything is directly integrated in Rust with the performance of a C, but without dealing with the memory management and all the pains that you can find. So yeah, I found really effective when I'm writing Rust because I feel safe, and the compiler it's your friend, it's like telling you, okay, you need to change this, and it really helps you to be more efficient and with cargo GlideP for sure, but it helps you to define better code. And yeah, right now when I'm writing Rust, I feel like I'm writing the good piece of software that I want. And just to jump on what you said before, for the performance, it was really insane because I remember dealing with regex, and regex sometimes it can be really CPU intensive. And when I used regex crate from Rust, I just observed milliseconds when I dealing with a lot of pattern matching in the string and say, okay, it's really, really fast. And it was just the first feature of the crate because you can activate more features on top of or the default features that you can find in crate. And it was more and more faster. When I saw that, I was completely surprised because with Rust, you can be really, really fast.
Yeah, and actually, for those of that are not as familiar with it, what is you've brought this topic up a couple times, which is about the ownership aspect. Like, can you provide a little context from your perspective? Like, why is that important? What did that switch or flip of a switch help for you in that case? I guess.
I think when you are dealing with distributed system or a lot of thread or concurrency in your application, you have to make sure that you cannot access the same object in the memory. And it's always the same topic because if you access, you can have a segmentation fault or an issue with your application. And sometimes just to make a link with Delta RS, when you are working with binding, sometimes you call, for instance, a library in C or C++, but you have to release the memory before going out because you can introduce memory leaks. Right. With Rust, the concept of ownership is to make sure that each variable has an owner. So it makes sure that it cannot be the case of having two threads, for instance, accessing the same space. So when you write the code and the compiler say, you're okay, it's fine. It means that you can really work in a way that you are sure that every piece of software, you have an ownership of the variables. And it's, for me, a new concept. I work with really a lot of programming languages because I love to switch from time to time, but with the principle of functional programming, for instance. But with Rust, I was surprised because it was a step for me as a software engineer to say, okay, maybe I need to learn again. So I started to know more about Rust and the concept, and I found like a bit unique for now because it's my learning, but I think you can have different programming languages, but with Rust in the ownership, once you get it, it's pretty fast. On the other part, you can find some issue, but the concept of ownership is a core about my findings into Rust.
Oh, no, that actually makes all the sense in the world. And frankly, that's actually part of the reason why I asked the question, because you had called out also the same thing. Like, when you compile the code, basically the compiler's trying to tell you, hey, this isn't good what you just did here. So it won't work, or it'll give you enough errors / warnings that you're like, okay, I guess I better rewrite that. And I know for folks that are saying like, hey, but I want to write something fast or something quick, this will slow me down. I'm like, yeah, it does. And if you needed something fast and quick and you didn't care about, how effective it was, you could always just write it in SQL, when it comes to data processing. And this is not a knock on SQL. It's a great language for that purpose. But I'm going, but if you're trying to manage all this data in which you're trying to prevent corruptions, you care about reliability, all these other natures, right? The fact that you actually are in essence given type safety out of the box, given memory management out of the box, and you don't have to think about it. Like this ends up significantly simplifying your workflow. And makes you, and just like you called out, which I think I'm glad you did, which is like it made your life like you basically become a better programmer because of it. So
yeah, true. And for me, you gain time over a period of time. Meaning, if you build something in Rust, you can go to the production without having a strange corner case in a scenario. If I'm taking Python, I like Python very much because I feel it's effective. The ecosystem is huge. It's spreading everywhere on all the technology. It's like the common glue at back market when we are working, because it's like the language from everyone. But it introduces a lot of typing. For instance, you use MyPy or the type checking, and you need to check this concurrency issue, and you need to add this one, and you add a lot of things on top of Python. With Rust, is like, okay, the simplicity is the feedback loop is really fast and really short for you, but when you go to production, you feel safe. Actually, I didn't see any issue on the Rust programs that I did because it was compiled, everything was fine. So it's okay. With Python, sometimes you can have a type coming and everything is down and say, oh, maybe I was a bit too fast for this one.
Yeah, I've done far too many of more than my fair share of exactly that. So no disagreement. So actually, we have a question about about if you're coming from PySpark, how to implement pipelines of Rust, what you need to take note of. I think we've already started that, but actually, I'm just calling that out to the person who actually asked the question. We're actually going to go back to that. But I actually did want to talk a little bit more about some of the contexts, and so that then our answer makes a little bit more sense. So, for example, you already called this out, Florian, but I did want to let's go through this. Let's talk about PyArrow. Let's talk about Ballista. Let's talk about Polars and even Data Fusion, for sake of argument, right? And anything else like these key packages that we really want to call out. So whichever one you want to go first, but I think we need to provide the users here, or so the attendees here, listeners here, this context of why are these various packages chosen, especially from even just from the Rust perspective, let alone on the Rust/Python bindings connectivity. So probably Arrow, right? I think probably that's probably the good one to start with.
Yeah, sure. And for Arrow, if I take the perspective from Python developer, it's PyArrow, because it was a bit the same. Arrow is a Rust crate, the core of Arrow, and you can use PyArrow that are the binding. Arrow is like the common space when you deal with it's many different things. It's the memory management is the way that the data is stored inside this structure and is optimized. It's a protocol because you can deal with different data formats and not having to think about what is the structure or what is the schema, what is the type of this schema. PyArrow is a common structure, and when you are dealing with a lot of different schema and metadata and types, it makes sure that you can find the right PyArrow one and be optimized. And you can find also Data Fusion that was created, and to have more SQL planner optimizations and connected to Arrow. So just to mention Delta LRS in this big picture, Delta LRS, the Python binding is using the Arrow crate through the Delta Lake crate. So you have the Arrow at the core to make all the data coming from Delta converted into the Arrow. And it's really efficient because it's really it's in Rust with memory management. And I think I said already a lot of nice things about Rust, but it's really convenient when you are dealing with different formats. And the community is pretty is intense right now because you have Polar, you have a lot of crates coming, and basically it's just to say, okay, I have JVM working on it, but if I'm using Rust, maybe I can optimize something on it and find a better way of dealing with it. So, and just to say that we also have from Script Delta communities, Kafka LRS, to make sure that you can also read Kafka and write to Delta using Rust.
Cool. We'll definitely dive into that in a second. But one of the things that I want, part of the reason I called this out, by the way, is basically for those that you may not know, Wes McKinney, who created Pandas, so very known person in the Python community, to put it lightly. He's also led the creation of Apache Arrow, right? And so it's basically this idea of where we're saying the best of both worlds between Rust and Python. Yeah, like Arrow is one of the core tenets to actually allow that. And by the way, Wes is the co-founder and CTO of Voltron Data. So they actually some interesting concepts like Flight SQL, ADBC, but just want to call that out. Like this Arrow being a important component that allows that basically the allows for the data management of things in essence. Okay, so how about before we go to Kafka Delta Ingest, just because, and not to mention I can probably get QP to dive into that a little bit too much, anyways. But like, how about like projects like, packages like Data Fusion, Polars? Like, there's seems to be a lot more activity around these things. Can you provide context of what these things are within the realm of the Python world or Delta Rust world, for that matter?
Yeah, I think for the Polar is it's in the name, but it's blazing fast data frame. So it means okay, maybe we have Python, and for instance, if we use Panda, you can have a NumPy or PyArrow just to make sure that you can be really fast. Polar is naturally fast because it's implementing in Rust. Mm-hmm. And yeah, I think it's using also the Apache Arrow column format, the memory model. So again, as you mentioned, Arrow is the core of everything on it. But yeah, I think it's also a good place for getting into Rust. For me, it was my strategy as well, because I heard a lot about Rust is one ranking. Ranked one at the most loved language in programming in Stack Overflow survey, but how I can deal at scale with Rust, and the community is really large, and you can implement because it's really helpful and benevolent. When I joined DeltaRS, QP just show me a lot of things to how to improve myself to be efficient with Rust. So it was really nice. The community with Delta Lake as well, and the script and all the teams were here to help me to say, okay, maybe you have to learn this, or you have to change this. So I think Rust is something that the developer wants to play with and find an opportunity to do. It's like, okay, maybe we need to rewrite this in Rust to see how it goes, and we see the performance gains to say, oh, look at the memory, look at the CPU, it's really fast, it's really nice. But it's like these kind of things, and you can have on top many different features that you can add for sure in Rust. But I think the core is to say Rust is for developers, so you want just to have a point of contact with it and say, okay, maybe I need to try this first and see how it goes.
Yeah, and so, by the way, I appreciate a particular call out that you actually sort of put it almost as a secondary, but I actually want to sort of bring it up because this is actually very helpful for the person who asked the question, like, somebody who came primarily from PySpark, what are the implementation pipelines of Rust? What do you need a note of? It's the part that the Delta Rust community went out of its way to basically make sure anybody that wanted to learn, like, there were people there to back up. And like, great call out to QP, by the way. So, but also, like, we have a bunch of other folks, in the Delta Rust community, but yes, since, QP is QP, we're going to all call them out first. But right, I really appreciate the fact that you called that out. Like, that was a lot of community members that went out of their way to help everybody, help and you're doing the same with other people too, by the way. Like, that's a natural segue here, right? You've returned that. You've went ahead and also, I see you on the Slacks, I see you, on the GitHub, and you're basically making sure everybody else can learn from it as well. And so the fact that we're all helping each other out to basically learn Rust, I think that's an important thing for the person who had asked about implementing pipelines, is that try something that you do know, sure, but like, hey, there's a bunch of folks here that actually really want to help you out, and please do join us. Because I think, as you can almost tell, there's a lot of us that are all super excited about Rust. Like, it's become a very geeky thing for all of us, and so note the fact that, like, Florian's a back market. I'm at Databricks and we're talking about a language neither of us are actually like technically part of either our company, yet we're both advocating strongly for the language just because again, I'm going to stop because you probably already overheard us talk about type safety and memory management. But the point is that it allows us to do things that we couldn't do. And then one final tidbit before we shift gears into more specifically about the pipelines and how you implement that in back market. Like with the Kafka Delta Ingest project, we actually had a video from last year with Tyler and Christian and Misha. These are folks from Script who basically talked about how they were able to, because of Delta Rust, build the Kafka Delta Ingest project. So for those who don't know what it is, it's to take Kafka topics and basically write them directly to Delta, like directly using Delta Rust. So in other words, it's not using Spark or anything like that. And again, Florian sort of called it out, how amazingly efficient this thing is. And so basically 2 vCPUs were basically streaming through, pun intended, right? Something that would require like 5-10 nodes of data distributed processing on a JVM. And in other words, I'm not trying to badmouth any particular project, so I'm just leaving it as JVM right now, right? And yet, literally, it was like 2 vCPUs on a single VM that could basically process this data. And just your eyes light up on exactly how much more efficient things can be. So yeah, just wanted to call that out. All right, we only have about I'd say 8 to 10 minutes left. So let's segue directly to the person's questions. Like, what are the things that we should note of now that we've given the background of Rust and given the background of Python and how back market has used this, in order to be able to implement these faster pipelines. And you came from a PySpark background too. So what do you think what are some key learnings or key call outs as you make that shift from PySpark to Rust from your perspective when it comes to implementing pipelines, excuse me?
Yeah, I can talk about the use case at back market. It was used, and I think we have a blog post if you want to have more information on the Medium page. But it was to deal with a subscription mechanism. So we wanted to have someone, a data user, to request for an access on Snowflake. For instance, I'm working on the finance team and I would like to have this table with this schema and this definition inside this domain, and we call it subscription. And the first use case for Delta RS was to say, okay, I need to trigger something because we have the silver and the bronze and make it available through Snowflake. But we wanted something really fast and cost effective because we are moving data from one cloud provider to another, so you can deal with a lot of huge egress cost. And we find a convenient API, Snowflake Snowpipe. So it's basically an API that received a lot of Parquet files and make things available inside one Snowflake table. So it was pretty useful use case. We deal with the fast ingestion with Databricks to make things really fast on the bronze and silver. And when someone requests from some data in Snowflake, we have a DAGs in Python working with Delta RS that fetch the subscriptions, look at the proper the right delta tables, silver or bronze, for instance, fetch all the files inside the partitions or the subscription that data was requested, and throw it into Snowpipe. So Snowpipe on the other side was connected to AWS S3 and get all the Parquet files and make it available inside the Snowflake tables. And we switch from Snowflake to BigQuery, and we are dealing with this kind of strategy because we have Databricks at the heart with a lot of data sets that we can create it based on events or CDC events coming from the database. So it means that when it's working with Snowpipe with this kind of system, you can switch to BigQuery or other storage as destinations and make things really convenient when you have different data consumers on the other side. So the switching was more about Python. The Rust was pretty useful to fetch the files, the partition, the schema, all the metadata, audit, and sometimes exploration with the data teams to work with small data sets. but not a writer implementation. It was the next step for Delta IRS. We have an experimental writer, but we don't use it because we use more about PySpark or the pipeline with Delta Lake at the moment. But it's really available, but we are just fine-tuning some authentication parameters or issues sometimes. And yeah, it's pretty, it is depending on the context when you're using the writer on your specific use case.
Right, gotcha. So let me, if I was still like sort of in this current state, because after all, we're still just like you noted, the writer's still very much experimental. Where it makes sense, at least right as of today, November 17th, 2022. So in other words, if you're listening to this podcast or watching this vidcast at a year from now, this is probably not the case anymore, and we'll probably already have another session discussing this. The context is like when you switch from PySpark over to Delta Rust, know which situation you're applying this to. Delta Rust is very reading is great, and this is the part where like you're processing fast. And while there is a project like Kafka Delta Ingest for that's basically production for writing Kafka topics into Delta, at least it's been used in production by multiple companies right now. In the case of the Delta Rust itself, portion of it, that part is still very much experimental because we literally what 2 months ago or 3 months ago had started basically putting that code base in. We've but took some of it from Kafka Delta Ingest and added a separate set of code base in order to get up and running. By the way, there is a project later on to reconcile the two. So, but nevertheless, the context is like for smaller data, it absolutely makes sense. For larger systems, it may still make sense to use PySpark, though over time we suspect that even that might start changing. So did I sort of wrap it up correctly, I guess?
Yeah, totally. It's the next step for us would be to improve the writer, the performance. We have to set up first a benchmark to see how we can.
Issue 933, I think that's the one.
Yeah,
rated. Yeah, specifically for that. Yeah.
and I forgot to mention on the reading part of the Delta IRS, you can find a Panda integration, so you can just easily go to Panda and have an exploration for the data scientist or data analytics to say, okay, maybe I know Panda, I know how to use it. So plugging to Delta IRS, it's really convenient, and you can have the time travel using the data sets and so on if you have some feature exploration with your machine learning use cases. So it's pretty convenient to have a Delta IRS with Pandas on top of PyArrow, on top of Rust. So it's pretty different layers of software programming, but it's really abstracted.
Yeah. No, actually, that reminds me. I'm going to have to ping you afterwards. We're going to have to actually write the blog about that, by the way, with the machine learning pandas, Delta RS, just because even though we're saying a lots of different things, it's from a code perspective, you're just running a couple imports. That's actually that's actually all you're really doing. You're calling a couple of imports, like import Delta Lake. By the way, for those who are using the Spark version, it's Delta Spark versus Delta Lake, which is basically it's the Python bindings for Delta Rust. So it's just import Delta Lake and import pandas, and then you're off to the races basically. So it's not we're explaining it horribly. It's actually quite simple to run.
Yeah. So. Don't be scared. It's really simple when you use it.
Yeah.
Behind the scene, we have a lot of things, and join us to understand more what's going on behind the scene. But yeah, it's really simple to use.
Actually, as a final call out, and this one I realize it's still too early, okay, but I figured why not, just for the fun of it. Are we trying to figure out right now how to distribute Delta Rust better with Ballista, or is that our current approach, or are we thinking of different approaches right now? I'm actually not sure about this one myself personally.
Really good question. I don't know actually. Maybe as a next step, I don't know. But for now, having the writer implementation is a good one with strong ones that you can use on production. Can be really nice steps. And yeah, the second one would be maybe have a more multiple data IRS working together or integrating into another crate. It could be a nice step.
Now, no, even though I did call that out, note the fact that in many of the use cases at back market, and actually many of the use cases in production, really, I've not needed to distribute Rust. I've just been able to go ahead and have the one thing. And usually we have our problems are whole, like as in, am I saturating the network connection with that one system? Okay. So yeah. So honestly, I'm asking the question just more out of fun.
Yeah.
Typically when you're running this system, especially in the read, but even on the write, yeah, our problem usually is we end up saturating the system anyways. So it's a whole other problem. So
But for the reading, actually, it's working well. It has been 2 years now that it's running in production to fetch all the metadata, schema, filters, and so on, and no issue on this side. So it's really strong for the read. On production use case, we are dealing it with a lot of pipeline inside back market on daily usage, so it's fine. For the writer, it's not the same. That's why you don't want to use it at the moment.
Yeah, but over time, I'm sure. And by the way,
for sure,
as a way for us to, for everybody watching this vidcast or joining the podcast later, come join us. Go.delta.io/Slack. We actually are very active with our conversations there. You find bugs, you have some better ideas. Absolutely, come talk to us. I think that's probably a good end point for us today. I think if we keep talking, you and I will just invariably go back to talking more about Rust anyway, since then we're going to bore the audience. So, any last tidbits of advice for anybody? Like, again, going into this space, like we talked a lot about it, but it just, if we're going to do the simpler version, any last tidbit of advice for anybody?
I would say start simple, join, and it can be an issue. It can be just fixing a small part of the Rust code base. Definitely, we will help you to learn and to find a good way of solving the issue with us. So join us. It's a really good code base, and every team member is really nice. And so it's a good opportunity to work with cool members.
Excellent call out. I do want to call out the fact that these folks are so nice. They're even tolerating my questions. So, hey, we're doing great here. Florian, thank you very much. I really appreciate your time. Again, this is the D3L2 vidcast podcast. I'm here with Florian from Back Market. He's a Delta Lake committer maintainer, focusing on the Rust and the Python bindings. Again, Florian, thank you very much. I really appreciate your time today.
Thank you, Denis. It was really a pleasure to be with you and to talk about Rust again.
Merci beaucoup. À bientôt.
Merci. Au revoir.